Hello watchers, welcome back with another video by CodeJit. And in today's video, we're going to see how you can implement linked list in JavaScript. So linked list is a kind of a data structure, kind of a linear data structure where each node is connected to the next node. Okay, so let's say if there is a node called 22, it will be connected to there will be a next pointer to it. There will be a next pointer attached to it, and that next property will be pointing to the next node, a node after that, whatever you can say. And similarly, so on, okay, like it goes in like it goes linearly basically. So that's how a linked list looks like. And basically the one of the benefits of using linked list is like in linked list insertion and deletions are like kind of efficient as compared arrays. Because let's say in array, if you want to insert something at beginning, then you have to reshift the index of all other items, you know, because in arrays, every elements every element is stored at a specific index. So when you add something at like a 0 index, then you have to reshift the all the elements after that. But in case of linked list, it's not the case. Like let's say if you want to insert something at beginning, okay, at head, you can say, and then all you need to do is like you just take the head and make it 10 and then reassign this uh, newly added node to head. Okay, and that's it. You don't have to like a shift the older in this case there is no index, so that's why we don't need to do so. There's no need of that basically. And you can see the time complexity of this is like overfed. But when you talk about like an array, in that case, like it will become overfed because you have to like reshift the index. Sorry. So I hope you get it. Like so, like now let's just jump into the implementation part. If you still didn't understand like what it is, then you can go and check definition of a linked list on the internet. But our main focus but our main focus in this video is going to be on more on link implementation part. Okay, so let's see how you can implement that. So I'm gonna let me open up our terminal, and I'm gonna like make a new directory called ts.js because we are doing this in JavaScript. That's why I'm keeping the name like this. And inside this, let's just open it in VS Code. And here, let me open linked. Let me just create a blank JS file because we don't need anything else, right? Okay, so let me just give us a little bit context, like how the how the things will flow, basically how things will work in it here. Okay, so in linked list we will have two different things, our head and tail. Head will always point to the first item in linked list, and the tail will always point to the last item in linked list. And there will be one more property. We are just keeping it for our ease. And that's gonna be like count. Count is basically will keep track of how many elements have been added so far. Like how many elements do we have in our list? So that's what counts will keep track of. Okay, and our node will consist of two things on the data itself, like 85, 22, 277, whatever you can say. And there will be next property. Our next property by default this will be null, our next property, but if there is any element after that, like it will be pointing to that node. Okay, if there is any node after current node, then that next property will be pointed to that node. Okay, so let's see first of all like how a structure will look like in JavaScript so that it will become more clear to you after that. So I'm gonna define my node class here, and there will be one constructor. In this constructor, we'll accept a argument, and it is called, and we'll call this a value, and let's assign this value to val. Okay. Okay. And there will be also a next property, as I said, and but by default this is going to be null. But if there is any other node available after that, then it's gonna be pointing to that. Then it will point to that node. Okay. So yeah, that's it. Like that's it in terms of node. Like now we have ready our like we now our node is ready. So we can start like it's gonna look something like this, like a node node, although these all nodes are different, these all nodes are going to be different. So this will be the structure of linked list. Okay, so let's see how we can do that. So now let's implement a class of linked list, and as I said, there will be three things. We will not accept anything in constructor, because if we when we will initialize, it will be blank by default, and then later we will be able to later we can add item and delete item, whatever we want to do. So okay, so inside constructor there will be three things. This dot head, because at the time of initialization it will be null, because there is no element available in this list, so we don't need to, so it will be pointing to null right now. And similarly, same goes with tail, right? It will be also pointing to null because there is no element. And there will be a count, you can say. Yeah, of course the count is something that will keep track of uh, how many elements are available in our node, our list basically, not node. So by default there is no element because it's an empty, so it's gonna be 0 for now. And yeah, that's it. Now we can start with like pushing. So let's see how you can push item, basically how you can add and insert item at last in linked list. Okay, although there are like a bunch of different methods available in linked list, although we will not be able to solve all of that in one video. But yeah, they will see like but yeah, I'll make another video for those different methods, but just to give you like clarity how it works and how you can define methods and all. That's why I'm making this video. So we're going to start with the push method. The definition of push method is going to be like it's gonna take a value and it will create a node with that value. Okay, and after that it will attach that node at very last in the list. So let's see how it works, how it's gonna work. So there will be a push method. Inside that we will accept a value as an argument, and we will create a new node equal to new, not some new, it's just a node. But I think we can also do it in this way, right? Because it's a val. I hope we do it in this way. Yeah, of course. So we have created our new node, and here we need to check a few things. First of all, we will check if if there is no node available in the list, which means it's an empty, right? In that case, what we are going to do, if this dot count equal to 0, okay, if that is the case, which means there is no there is no item available in our list. Okay, if this dot count is 0, then simply just assign this dot head equal to new node, and this dot tail equal to new node. Okay, if there is no element available in our list, in that case we're gonna simply like assign head and tail to our new node, because this will be the only item which exists now in our list. Okay, after adding this one, because it's the only one, so that's why we're gonna assign it to head and tail, because the first item and the last item, the both will be the same in case if it's an empty list. Okay, and if it's not that if this is not the case, then what are we gonna do? Oh, we're gonna like simply take this dot tail, this basically we're gonna simply take this dot tail dot next, and we're gonna assign it to new node. Let me explain, explain it through this like little example. Let's say we have a 3 item in our list, okay, and we are adding 4. So our current tail is like 3, right? So we are just adding a 3 dot next equal to 4, the item that we want to add right now. Okay, the new node, you can say. Okay, so now we have successfully added the next item at our this dot tail. But here is things to note. Here is the thing to note. Because now there is new item in our list, and there is like a new item in our list, and that too is like at last position. So that's why our tail will now change. Now our tail is gonna be basically, now our tail will change, right? Our tail is no longer a 3, now it's a 4, because we just added that. So in that case, we also need to update this dot tail equal to new node, not new node date, new node dot next, but it's a new node. Okay, and that's how if there is already an item, if there are items available in like list, then in that case you can define it in this way. Just take a tail and update the next item of the current tail to new node, and also update the tail, because our old tail is no longer the old tail. Our new tail is something, because our new tail is now new node. So this is the last item that we added, because it's the item that we added at last position now. It's something like that. And once you have done that, now you can simply increase the count. It's important because you have just added a node. So that's why, to make sure, just add a count, increment a count, because there is a one more item added, because we just added one item in our list. And at last you can simply return new node. Now let's check if it now let's check if it is working fine or not. So to check that, we will first of all initiate our list, and let's gonna instantiate this one. And what are we gonna do? We're gonna simply push something 3, and after that 2, and after that 1. And now let's console log list dot head. Yeah, let's just console list right now. Okay, and node linked .js, and here you can see like our first node is 3, second node is 2, and the node after that will be 1. The similarly here you can see like our tail is 1 and the head is 3, because after that this should look something like this: 3, 2, and 1, right? Because that's how it will look. So that's why 3, 2, 1. So if it's in this format, then our head should be 3, our tail should be 1, just like you can see here. Our head is 3 and the tail is 1. So which means like our push method is working fine. And yeah. Okay, so now let's take a look at like how you can implement a pop method. Pop method means deleting something from the last of like deleting the last element in linked list. Okay, removing last element in linked list, and that's what pop means. So we are going to define pop, and we don't need to take any argument here, because we just going to delete our last element here, right? So here there are some of the things you need to there are some of the things you need there are some of the things that you need to keep in mind. It's like if there is only one element in the list. Okay, if there is only one element in our list, which means not 0, 1. If there is only one element in our list, which means like it will look something like that. It will look something like this, right? If there is only one item in our list, then what are we going to do? If we are deleting and that last element, which means after that there will be no item in our list, right? So in that case we need to make it null, like we have to make our head to null and our this dot tail to null as well. Okay, but if that's not the case, if there are some items available in our list, then things will be quite different. So let's see how we can do so. So let's say we have a similarly we're gonna take example of 1, 2, 3, and 4. So now if you want to pop this item, because of pop, if you are deleting this item, right? If we are deleting this item, what we need to do here is like we have to reach at this point of like we have to somehow we have to like find out how to get this element, and after that all we need to do is like set the next property of this to null, right? And it will automatically it will automatically get removed from our list. And how we can do so? The one of the way of doing this could be like we will take our head, which is like currently 1, and we will loop through it until we reach at n-1, which is like a second last position. Okay, and once we have reached at this point, we are simply gonna strip. We simply gonna like stop. We are simply gonna stop and like set the next property of that node to null. And I think after that this will work. And that's how it will work, I think so. So let's see how we can do so. So let's define a variable called current. So this current will currently point to our head. Okay, and there will be one while loop. This while loop will run until, because our like a current head is like 1. Okay, this while loop will keep running until there is next of next. Now what does it mean? Like if there is a next of next, like if like there is a next of next property, like there is 1 and there is a next 2 and there is a next 3, right? So in this case it will run. After that there is 2, there is next, and there is next after that. So in this case, even in this case it will run. And now and once it will reach at like 3, and then there is next, and there is no next after that. So in that case it will simply stop. So it will stop at third position. Okay, so that's how you can like basically reach at second last position. It is like a very naive approach, although you can think you can think something better. Okay, well, for right now let's just check it like how whether it works or not. So if there is a current, if there is a next property of current dot next, if that is the case, what we're gonna do, like we're gonna update our current to current dot next, and we're gonna simply assign the next property of this to null. And also because we have now we have deleted our last node, so that's why our new tail will be current. Our new tail will point to current because this is our new tail. Okay, and that's how I think this one should work now. Let's see if it works or not. So let me return. We will not return anything here. This dot count minus minus, because we just deleted one item from our list. And now if I run it, because we haven't popped anything, so let me just pop something. Pop. So if I pop this, then after that it should look something like this, right? Now our new head will be 3 and our new tail will be 2. and our old head was 3 and our old tail was 1. Now let's see if it works. So you can see like it is working as expected. Like our new head is 3 and our new tail is 2 and our count is also updated. Our count also get updated. So okay, so which means it's working. So that's how you can implement pop method. There might be some edge cases that I'm missing, although I'm not sure of right now, but it is just to give you an like it is just to give you an overview like how you can implement a pop and push. There are also different methods available in it, like shift, unshift, insert, delete. Uh, by insert I mean like insert at given index. I can, although there is no index, I know, but at after like certain element, and delete element, delete a node from given index. And there will be also a reverse method. So these are like quite a few important methods that you can define in your linked list. Okay, so now we're going to see like how you can implement shift method. Shift method simply means like uh, deleting something from beginning. Okay, if you want to delete something from beginning, in that case, like you need a shift method. So let me show you how you can do so. So there will be shift method, and inside this, yeah. So it's a shift method, and what we need to do here. Let's say we have a similarly, let's take example of 1, 2, 3, 4, 1, 2, 3, 4. Okay, and if we want to delete something from beginning, what we need to do here, like we need to first of all check whether if it's like the same as pop one. Okay, if the count is 1, if that is the case, then simply make your head and tail null, because after deleting this last item there will be no items, there will be no item available in our list, right? So in that case our head and tail will be pointing to null. Similarly, uh, now after that we can see like what we can do. Else, if that's not the case, if there are like more than one elements available in our list, so then what we'll do, we will store our head in temp, the current head, this dot head in temp, which is like a 1, and we'll make our we'll make and we will reshine our head to temp dot next, which means 2. Okay, so now our head will be 2, 3, and 4, right? And after that just decrease the count, and I think that's it. I think, yeah, that's it. Okay, so let me just remove this pop method, because if we do so, then we will not have any element in our list after that. So now let's just try list dot shift, right? And you can see it has successfully removed 3 from our list, which is like a current head, which was like old head. Okay, so that's how you can like implement shift method, and it's a kind of a, and it was a very easy, right? It's a much easier than like a pop method, because in pop case like we had to traverse through every single node, I think in that case like in pop method, like our time complexity was O of n, because we traverse through each and every node. But in case of shift, it is like a O of 1, because we don't need to do any traversal here, because we didn't do any traversal sort of thing here. That's how you can implement shift method. Let's see how you can implement shift unshift as well. uh, Unshift is like adding something at beginning. Okay, so let's see. Unshift. Okay. So unshift will take an argument as a value as an argument, and after that we will create a new node. New node equal to new node val. Okay. We will create a new node on the basis of the given argument, and after that we will see simply. I think it's also the same as on this one. So the first check will be the same, which is like if the count is 0, then simply assign this dot head equal to new node and this dot tail equal to new node, because there is no element. There was no element at the time of inserting this. But if that's not the case, then what are we gonna do? We're gonna simply take our new node dot next equal to this dot head, right? Which means if our let's say our the node that we want to add is like a 5. Okay, and our order list was 1 2 3 4. 1 2 3 4. In that case, what will happen? Our new node dot next will become this 5 1 2 3 4. It's not a currently this is just our new node, because we just assigned the next property to 1, and after that we can like simply assign this dot head to our new node. Okay, and if I'm not wrong, then after that our head will be also this 5 1 2 3 4. That's why, yeah, it was very simple, right? I think let me just see like if it if it is working as expected or not. So let's unshift something. Let's unshift 5. Okay, so we are getting count 3. Why is that? Okay, so we haven't added anything. Like we haven't incremented our count after inserting adding an element. So now if I'll take a look at this, then you can see like our current head is 5 as expected, and our tail is 1. Yeah, it is also as expected, because our main list looks something like this: 3 2 1. Okay, so yeah, our unshift is also working fine. That's how you can implement these basic methods in linked list, and there are also these methods which we'll discuss in like a later video, but for now I think video is too long, so let's just keep it simple. Just let it be. So I hope you like this video. If you liked it, then don't forget to hit the bell icon and subscribe this channel. I mean, first subscribe this channel, then after that hit the bell icon. I'll see you in the next video. For then, goodbye. See ya.